presentation in understanding the solar system. My name is Zakhia and my ZID is Z5421776, and here is my license for photo ID. Now let's get started. Jonas Kepler suggested 3 laws of planetary motion in the early 1600s. Kepler was able to summarize his mentor's Tochi-Boschi's precisely gathered data into 3 sentences that summed up the motions of the planets in our solar system, centered around the Sun. Let's go over these 3 laws. Law number 1, planet moving in elliptical orbits with the Sun as its focus. Law number 2, a planet covers the same area of space in the same amount of time no matter where it is in its orbit. In other words, there is an imaginary line joining a planet to the Sun will always sweep out an equal area during an equal time interval. And law number 3, a planet's orbital period is proportional to the size of its orbit, its semi-major axis, meaning the planet will move faster when near the Sun and slower when further away from the Sun. Now let's go over question 9. The answer to question A is yes. The planet does move as the Sun orbits because the Moon as a percentage of the Earth's mass is much higher than that of the Sun, which means the move's gravitational force will impact the Earth's gravity more than the Earth would on the Sun's gravity. Another reason is because the Moon is much closer to the Earth than the Earth is to the Sun. The planet has become the principal body and has a different semi-major axis and a much larger orbital period. That's the answer to question B. In question C, each scenario's center of mass is inside the solar, while the precise locations of each vary according to the mass ratio of the Sun to the Earth, as seen below. So over the first one, center of mass in the middle, center of gravity is much closer to the Sun and the Earth due to the vast disparity in gravity and mass of each object. Example 2, the center of mass is also in the middle, however the mass planet has doubled, meaning the center of gravity would be further away from the Sun, although this wouldn't even matter due to the small size of the Earth compared to the Sun. And example number 3, the center of mass is more to the left as the Sun mass was increased, causing the planet to orbit in an elliptical orbit, whilst the Earth's trajectory was unchanged. This caused the center of gravity of the planet to move closer to the Sun's center of gravity. Now let's go over questions 11 and 14. The distance between the grid line is 73844,015 kilometers, or 0.49 astronomical units. And question 14. These results do indeed follow Kepler's third law, as the ratio of squares of the orbital period to the cubes of the semi-major axis do remain approximately equal. In other words, the period of the planets to orbit the Sun increases rapidly with the radius of its orbit. Questions 15 and 16. 15a. Mercury has a faster orbital velocity with a speed of 47.9 km squared. Neptune has a slowest orbital velocity with a speed of 55.5 km per second. And question C, a planet further away from the Sun not only has a longer path than the closer planet, but also travels slower since the Sun's gravitational pull on it is weaker. And things I've learnt whilst completing this experiment: the shape of the orbits. Identification of planets in our solar system was made based on the orbital characteristics. Effect of changing mass. Changing the mass of the planet was found to impact its orbit. Expectations regarding orbital velocities. Anticipations were made about which planet of the solar system would have the fastest and slowest orbital velocities, as just discussed. And summary and lessons learned. The overall understanding gained from this experiment includes insights into gravitational forces, orbital dynamics, and application to Kepler's law was highlighted. This experiment served as a valuable hands-on exploration of central mechanics, providing practical insights into factors influencing planetary orbits and reinforcing concepts learned in this course, particularly Kepler's laws. Thank you.